We've looked at a method called FTCS, which is fully explicit, and then we looked at a method called Lawsonian, which is fully implicit. There's actually a method which is in between. It's called Crank-Nicholson method. We will not solve a problem, but I'll just put it down. So it gives you the best of the two worlds. It's known as the crank. So the last thing I would say is to get the best of FT, CS, and so I think FTCS is fast but not stable. Lawsonian is slow. Here's something which doesn't have the problem of stability because it has implicit, but it doesn't have the slowness of Lawsonian, so it's faster. So what we do is, instead of trying to do an update, which is, remember both the methods differed in how they did the d square dt dx. If you go here, this one, you can find it. Yeah, here it is. So here this one used, the FTCS used TI j plus 1, I, everything was I. If you look at Lawsonian, it used I plus 1, I plus 1. So it basically uses the average of the two. Well, not average, but has a weighting factor, so which I'll write down in just a bit. So what this one does is it approximates the second derivative as follows. Plus ti plus 1j divided by delta x squared. So that is the fully implicit term, the first one. But remember, it's in front, there's a gamma in front of that. And then you do plus 1 minus gamma ti j plus 1 I j plus so this, the second term here is basically the fully explicit method. Implicit explicit, and then gamma is the tuning parameter. If you put gamma equals 0, you have the explicit, or known as the FTCS. If you put gamma equals 1, you have the implicit. And if you put gamma equals half, it is known as the Crank-Nicholson method. Okay, I'll write down the formula for Crank-Nicholson and I'll stop. So the formula, which is after you take that d squared dt dx and you put in the equation, will look like this in terms of f. Let me just write the Crank-Nicholson one. They're the most widely used. Minus f I plus 1 j minus 1 2 1 plus f di plus 1 j equals f di j plus 1 plus di j minus 1 plus 2 1 minus f comma j, where f is alpha delta t Okay, so what's not known is these are typically unknowns, and everything here after the equal to is known. So you again end up with an AX equals B system, unfortunately, but it is more stable than the other.